So here let us find the Fourier transform of x into e power minus mod x. So since we are dealing with the Fourier transform, so we have to write from minus infinity to plus infinity. This is 0. So here we have negative numbers, right? So in this negative number, the mod x will be minus x. So here we have positive real numbers. Here the mod x will be x. So accordingly f of x will changes here. Okay. So first let us write the formula of the Fourier transform. So now we have to write the values of, we have to split this integral from minus infinity to plus infinity as minus infinity to 0. Minus infinity to 0. So whereas your f of x will be e power, so x into e power minus, here mod x will be minus x, right? Into e power I u x into dx, right? So plus from 0 to infinity, so x into e power minus mod x equal to x into e power I u x into dx, right? Now let us add these powers. So this is nothing but, right? So now this is nothing but minus infinity to 0. So x into e power minus into minus plus x plus I u x into dx plus 0 to infinity x e power minus I x minus x plus I u x into dx. So this is nothing but minus infinity to 0. So x into e power, we can take x common. So 1 plus I u into x into dx plus, so 0 to infinity. So x into e power, we can take minus x common. So 1 minus I into u into x into dx, right? So now let us calculate the integration of this by applying the Bernoulli rule. So this is the first function. So first function, so write that in bracket, into integration of second function. What is the integration of second function? So e power 1 plus I into u into x divided by 1 plus I into u minus differentiate. We should perform differentiation integration until we get 0. What is the differentiation of x, which is 1? What is the integration of this? It is e power 1 plus I into u into x divided by 1 plus I into u whole square plus 0. X equals to minus infinity and x equals to 0. That is the limits. Plus again. So here, okay. So we have to apply the Bernoulli rule here. After that, we have to find the upper limit. Put x equals to 0 here. 0 into anything is 0 minus e power 0 is 1 divided by 1 plus I into u whole square. This is the upper limit minus, substitute x equals to minus infinity. So my e power minus infinity is 0 minus e power minus infinity is again 0, right? So plus here x equals to infinity, that is the upper limit. So e power minus infinity is 0 and minus e power minus infinity is also 0, right? Minus, this is the upper limit, minus the lower limit x equals to 0. 0 into anything is 0 minus e power 0 is 1 divided by 1 minus I into u whole square. So this is your Fourier transform of x into e power minus mod x. So let us do the next problem. So obtain the Fourier transform of the function f of x equals to 1 minus mod x, whereas the mod x is less than or equal to 1 and 0 whenever mod x is more than 1, right? So first let us, what do you mean by mod x is less than or equal to 1? So it's nothing but x is more than or equal to minus 1, less than or equal to plus 1, right? And here mod x is more than 1 means x is more than 1 and less than minus 1, right? So what happens? So we have to draw a line here. So from minus infinity to plus infinity. So we have to mark a 1 here and a minus 1, right? So from minus 1 to plus 1. So we have f of x equal to what? Which is 1 minus mod x. And from if x is less than minus 1, we have f of x equal to 0. If x is more than 1, we have f of x equal to 0. So first let us write the formula of the Fourier transform of the function. Okay. So now let us split the integral from minus infinity to plus infinity as minus infinity to minus 1, whereas your f of x is 0, minus 1 to plus 1, whereas your f of x equals to 1 minus mod x, and 1 to infinity, whereas your f of x is 0. So we have substituted the value of f of x here in this range. So now, so this is 0, right, and this is 0, though we have only this thing from minus 1 to plus 1, 1 minus mod x into, so e power I u x into dx, right. So now, since mod x is there, we have to split this integral from minus 1 to 0. So minus 1 to 0, we can see the negative real numbers, whereas the mod x is minus x. So what happens? So 1 minus mod x is minus x into e power I u x into dx, plus from 0 to 1, we have positive real numbers, whereas mod x equal to x. So 1 minus mod x equal to x. So e power I u x into dx. So this is nothing but, so minus 1 to 0, so 1 plus x into e power I u x into dx, plus 0 to 1, so 1 minus x into e power I u x into dx, right? Okay. So now let us find the integral value of this by applying Bernoulli rule. So first function, and the integration of second function is e power I u x divided by I u, minus perform differentiation integration alternatively with alternative sign, right? So the differentiation of 1 plus x is 1, and again the integration of e power I u x by I u is e power I u x by I square. I square is minus 1 into u square, plus the differentiation of 1 is 0. We have to stop at this stage. This is the lower limit and upper limit, plus repeat the same thing, just apply the Bernoulli rule for this. So first function and integration of second function is e power I u x by I u, minus the differentiation of, we should perform differentiation integration with alternative sign. The differentiation of 1 minus x is minus 1, and the integration of this is e power I u x by I square. I square is minus 1 into u square, plus the differentiation of minus 1 is 0, right? So now here we should find the upper limit, put x equals to 0 here. So it is e power 0 is 1, so 1 by I into u, minus e power 0 is 1, so 1 minus into minus plus u square. This is the upper limit, minus substitute x equals to minus 1, so 1 minus 1 will be 0, minus into minus plus, so e power minus I u divided by u square, plus, so here, so if I substitute x equals to 1, 1 minus 1 will be 0, minus into minus plus, plus into minus is minus, so e power minus I u divided by u square, upper limit minus lower limit, put x equals to 0, 1 minus 0 1, e power 0 is 1, 1 by I u, minus into minus plus, plus into minus is minus, so 1 divided by u square, right? So now, so this is equal to, so 1 divided by I into u plus 1 by u square, and here we have minus e power minus u by u square, minus e power minus u by u square, minus 1 by I into u, minus into minus plus 1 by u square, right? So we can cancel this. The remaining thing is 2 divided by u square. If I take minus 1 by u square common, so we have 2 times e power minus I into u, right? So 1 by u square plus 1 by u square is 2 by u square. If I take minus 1 by u square common, so we have 2 times e power minus I into u. So this is nothing but so 2 by u square. You can do the further simplification. So if you want, you can leave this as it is. You can take 2 by u square common. So it is 1 minus e power minus I into u. So this is the Fourier transform of the function.